first we are going to see some questions from the digital logic gate session. So I've been receiving a lot of requests to do the video on digital logic gates. So here it is. And before going into the problems or the questions, we'll be seeing about the very basics of digital logic gates. For example, Nand gate, NOR gate, OR gate, NOT gate, XOR gate, XNOR gate. These are the basic gates, right? So we'll be seeing the basic ideas, that is how they work, the truth table, the symbol and all, on a very pure exam point of view approach. Okay, so first let's see that. So the basic gates are, first let us start with the AND gate. AND gate means the symbol is like this. This is your AND gate. If A and B is the input and Y is the output, the truth table will be like this: A, B, Y. Then 0, 0, 0, 1, 1, 0, 1, 1 are the combination of inputs I'm going to apply. And the outputs that I'll be getting is, for 0 and 0, the output is 0. 0 and 1, the output is 0. 1 and 0, the output is 0. 1 and 1, the output is 1. Now, from the truth table, it is very much clear. When both these values, that is A and B, is 1, only then your output Y will be 1. That is the case for a AND gate. Next, for a OR gate, the symbol is like this. Like this, okay. So, if A and B are the input, Y is the output, the truth table will be looking like this: A, B and Y. For 0, 0, 0, 1, 1, 0 and 1, 1, here whenever any of the input is 1, your output will be turned as 1. So 0, 0, the output is 0. 0, 1, the output is 1 because B is 1 here. Here also the output is 1. Here both the outputs, here both the inputs are 1, so the output is also 1. So that is the case for a OR gate. Now for a AND gate, the output equation is like this: Y is equal to AB. Now, when you are solving Boolean expressions, you really need this. Or when you are solving the problems on logic gates, you need the equation. So, for the AND gate, it is Y is equal to AB. And for OR gate, it is Y is equal to A plus B. That is the case for AND gate and OR gate. Next is NOT gate. NOT means whatever you are going to give it, it is going to complement. That is the case for a NOT gate. So, the symbol is like this. Just a triangle and a circle in front. So, triangle and circle. So, there is only a single input and the output is Y, which is the complemented version of your A. So, A and Y. For A is 0, output is 1. 1. If it is given as input, then output is 0. Just to complement your input, the NOT gate is working. Okay. So, that is all about AND gate, OR gate and NOT gate. Next, we are going to talk about NAND gate, NOR gate and later on other gates like XOR and XNOR. Now what is a NAND gate? NAND gate, we have talked about AND gate. Now if you put a NOT in front of the NAND gate, so whatever the output which was previously, it will be complemented now. Okay, so that is the NAND gate. Okay, what I will do is I will draw the truth table here. Okay. So this is AND gate. Now NAND gate. NAND means AND plus NOT. AND plus NOT or AND into NOT. Anyway, you are going to combine these two. That is, whatever output is coming with the AND gate, you are going to complement it. That is the working of a NAND gate. Now the symbol is like this. The symbol I am going to draw it here. A and B are the inputs. Then you put an inverter in front of the AND gate and you get a NAND gate. So this is the symbol of your NAND gate. What will be the output equation for your NAND gate? Output equation is very simple. Y is equal to AB bar. That is whatever your previous AND output was, you are going to complement it. And how will the truth table of NAND gate? My inputs are A and B. My output is Y. Okay. So, for 0 and 0, you know that both the inputs are 0. So, what will be the output for an AND gate? AND gate output will be 0, right? But for the NAND gate, its complement you have to take. So, it is 1. Then, for 0 and 1, for AND gate, it was 0. So, here 1. Then for 1 and 0, for AND it was 0, here it is 1. For 1 and 1, for AND gate the output was 1, here it is 0. So this is how, okay, so you won't be able to see this. I'll write the truth table here, okay. I'll write the truth table of NAND gate here, A, B and the output is Y. So 0 and 0 the output is 1, 1 and 0 the output is 1, 0 and 1 the output is 1, and for 1 and 1, usually you take 0, 1, 1, 0, then 1, 1. Then for 1 and 1 the output of NAND gate is 0. So if you see this truth table and this truth table, see this here, first 3 outputs are 0, 0, 0, then 1, here 1, 1, 1, 0. That is the truth table of NAND gate is exactly the complement of the AND gate truth table. This is very basic things, everybody will be knowing. Anyway, I am just saying for the basics before doing the question. Okay, so that is the truth table of a NAND gate. Now we are going to see how the NOR gate and the truth table is going to look like. Okay, so we already have a OR gate here. So this is our OR gate. So this OR gate is A plus B. So NOR gate will be Y is equal to A plus B complement. That is, you can say here also OR plus NOT. And the symbol will be, okay, I'll draw the symbol. The symbol is just putting a bubble in front of the OR gate. So this is your NOR gate symbol. A, B, then a NOT. Now the truth table I am going to draw A, B and Y. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, so what was the case for a OR gate? The truth table will be exactly the complement of it. So for 0 and 0, the output of OR gate was 0, right? Here it is 1. Here also for 0 and 1, the output was, for OR gate it was 1. So here it is 0. Here again it is 0. Here again it is 0. So this is the truth table of a NOR gate. So here this is the truth table, exactly the complement of, that is output is exactly the complement of your OR gate's truth table. See 0, 1, 1, 1, 1, 0, 0, 0. Okay, so that is the case for a NOR gate. Next, the two other famous gates are XOR gate and XNOR gate. If you see, maximum questions will be from NAND gate, NOR gate, XOR gate and XNOR gate. So we are going to see the XOR and XNOR. First, let us see the XOR gate. So XOR gate, it is represented like this. A, B and Y. This is your XOR gate. Now the equation for XOR is Y is equal to A B bar plus A bar B is your equation. This equation you need many times. So just study this if you don't know. A B bar plus A bar B is your equation. The truth table is, I'll show you, A B and Y. For if A and B are having different values, the output is 1. If A and B are having same values, for example 0, 0 or 1, 1, the output is 0. Likewise, the XOR gate is working. So for 0 and 0, 0 and 1, 1 and 0, 1 and 1, I am going to write the output. So for 0 and 0, what will be the case? 0 and 0 both are same. So the output is 0. 1 and 0 different. So output is 1. Here again different 1. So 1 and 1 the output is 0. So this truth table of logic gates are very easy to study if you know the equation and all. So this is the case for a XOR gate. Okay, so this is XOR gate and XNOR gate is the complement of this XOR. I'm going to draw the XNOR gate. So this, if this is XOR, then how will your XNOR look like? There is a NOT in the front. See, A, B, Y. This is your XNOR gate. And the equation is Y is equal to A bar B bar plus AB is your equation. And the truth table is again like the previous cases, it is just the complement or the output is a complement of this one. 0, 0, 0, 1, 1, 0, 1, 1. I'm going to write the output values. For same cases, the output is 1. And if the inputs are different, that is, if 0 and 1 is coming, then the output is 0. Okay, 0, 0, it is 1. Here 0, here 0 again, here it is 1. Now, if you find the truth table difficult to study, just look at the equation here. That is A bar, B bar means 0 and 0. See, 0 and 0. And A, B means both A and B are 1. Here both A and B are 0. So, the output is high or the output is 1 for these two conditions. That is for 0 and 0 and 1 and 1. For other cases, that is for 0 and 1 and 1 and 0, the output is 0. Here again, if you see, the equation is A B bar plus A bar B. That is 1 0 plus 0 1. See, 1 0, 0 1 and 1 0. So, for these two combinations, the output is 1. For other combinations, the output is 0. So, likewise, you can study the working from either the equation or from the truth table. Anyway, both are easy to study. Now, these are the basic gates of digital electronics. The universal gates are Nand Gate and NOR Gate. And now we are going to do some problems from the digital gate area. Okay. Question is this. For the circuit shown below, output F is dash. Okay, so this circuit is a connection of 3 XOR gates. These gates are XOR gate. You should be able to identify from the figure that which gate it is. That is why I have drawn all the diagrams or the symbols of all the gates along with the truth table and all. Okay, so this is XOR gate. If there is a circle in the front, it is a XNOR gate. This is XOR gates. Now, we know that the XOR gates will give the output as 1 when the inputs are different. When the inputs are same, the output is 0. That thing should be also kept in mind. Here, I am going to give a X input to both the input lines of my first XOR gate. So, what will be the output of the first XOR gate? It will be 0 only, right? Because here both are X only. So, when X is equal to 0 or X is equal to 1, if both the 0 or both 1 is coming, means the output is 0. So, first XOR output is a 0. Then this 0 is being fed with an X value to the second, that is the second XOR gate, right? Now, what will be the output of your second XOR gate? That can actually vary, right? So, X can be either 0 or X can be 1. Now, if X is being kept as 0 and along with that as 0 is coming, what will be the output? It will be a 0, right? Now, if X is 1 and then it is being fed with a 0, right? So, 0 is here, and if X is 1 means what will be the output? It is 1, right? If you see this and if you see this, so what is coming as the output of the second XOR gate? It is X only, right? Here we are going to XOR 0 and the input X. So, the output of this XOR gate is whatever value is coming as X, that is whatever value we are going to give us the input value X, it is going to come as the output of the second XOR gate, right? So, I will explain it once again. See, for the second XOR gate, we are going to fix the input X and we are going to fed a 0. Okay, the output we are going to test. The X value can vary 0 and 1. Then along with it, we are going to give a 0. So, 0, 0. So, what will be the output of the XOR gate? If 0 and 0 is coming, the output is 0. If 1 and 0 is coming, the output is 1. So, this is same as your X value, right? So, that is why I have explained. If you are going to feed a 0 with an X input, that can be either 0 or 1, the output will be X only. I hope it is clear. Next, this X is fed with again another X is coming. So, what is the value? X and X. So, the value is 0. Okay. So, what is the output of this circuit? It is a 0. F is equal to 0 is the output of this circuit. The correct answer is option B is your correct answer. So if you are approaching such circuits, don't skip these questions. You know the basics of all the gates, right? So try to solve it. If it is time consuming, leave that questions for the end of the examination and try to solve it. Don't skip these questions. The next question is this. For the logic circuit shown in figure, x is equal to 1, x is the output, x is equal to 1 for A, B, C. That is for what combination of A, B, C, which are the inputs, the output x is equal to 1. The options are A, 1, 0, 1, B, 0, 0, 1, C, 1, 1, 1, D, 0, 1, 1. So I have not included very simple questions in this video because we have done in our earlier videos simple questions, right? So these are little bit difficult questions. Not very difficult, but a little bit difficult questions. Okay. So, for what combination of A, B and C, the value of x is equal to 1? Let us try to solve it by looking at the AND gate here. So, there is a AND gate here. There is a XOR gate here. There is a XNOR gate here. I hope you can identify these gates. These are an AND gate. This is a XNOR gate. This is a XOR gate. Okay. So, we have AND gate at the output, right? So, in order to make the output of an AND gate as 1, all the inputs should be is equal to 1, right? Only then the AND gate will give a output as 1. So, that is the case. So, that is the truth table of a AND gate. So, here if you see, one input is coming from the gate of the output of XOR, then one input is coming from the output of XNOR, and one input is directly fed as C. So, one thing is sure that C should be equal to 1 for x is equal to 1. Right. So, your C value should be equal to 1. Now, we need to find the value of A and B. Now, if you see this XOR gate, it is having one input as C, one input as B, right? So, one thing is clear, C value is equal to 1. Now, for what value of B, the output of this gate is equal to 1? Because if the output of this gate, that is the XNOR gate, is equal to 1, only then the next input of the last AND gate is also 1, right? So, we need to make this also 1. So, for that, what combination of B and C we should take? Anyway, one thing is clear, C value is equal to 1. So, it is a B, 1. What is the value of B? We know that the output of XNOR is equal to 1 when both the inputs are either 1 or both the inputs are either 0. That is, either both the inputs should be 1 and 1 or both the inputs should be 0. That is, for both the inputs should be same, the XNOR gate is giving a 1. So, if you have trouble in this, just pause the video and look back. I have explained while explaining this XNOR gate here. So, C is 1 means B should be also 1, because if both the inputs are 1, only then the output of XNOR is 1. So, B value is also 1 since C is 1. Now, we have two values here. Now, we have B is equal to 1 and C is equal to 1. Now, we need to find the value of A. And let us by looking at the options, we cannot really predict because option C is 1, 1, 1. Option D is 0, 1, 1. It can be either. So, let us look at the A now. Now, A and B are connected to your XOR gate, right? So, XOR gate input is A and B. And the value or the output of XOR is 1 when these two are different, right? That is, I'll write it here. For XOR gate to be equal to 1, that is, for XOR gate the output to be 1, your input should be either 0, 1 or 1, 0. Here B is 1. So, what will be the value of A? A has to be 0. A has to be 0. So, only then the output of this XOR is 1. Only if the output of XOR is 1, then the third input of the AND gate is 1. Only then your X value is equal to 1. So, the combination for A, B and C is equal to A, B, C is equal to 0, 1 and 1. The correct answer is option D is your correct answer here. Okay, so I hope this is clear. So this is how you troubleshoot the questions. If such questions are being asked, it is to find the input combinations to make that output as 1. You need to do it like this. That is, you need to first check out for any one option or any one input which is sure. Then give options for the other inputs. Okay, I hope this is clear. The correct answer is option D. Minimum number of Nand gates needed to implement the Boolean function a plus ab bar plus ab bar c. Now, while there will be questions like that, that is how many number of Nand gates is needed for realizing a particular function. Either you have to apply De Morgan's law, either you have to change a POS to SOP form, or you have to simplify the Boolean expression or apply double complement. These are the 4 options. I'll write it here. So when you are approaching such a question, you have to either go for, first one is either Boolean simplification, that is try to simplify the expression. Okay, Boolean simplification, or second one, try to apply De Morgan's law. Then third approach is try to convert SOP to POS, or in reverse, try to convert a POS expression to SOP expression. Then fourth one is taking of double complement. So if you face such a question, that is how many number of NAND gates is needed or how many number of NOR gates is needed to realize an expression, you have to go for either 4 of this. There can be other options also, but mainly you can do these type of question by applying any of these 4 options. Here this is a very simple expression, right? So if you see the expression also, all these terms are having A as common. So we need only Boolean simplification here. We don't have to go for De Morgan's law or either SOP or other methods. Okay, so we can do this by simply simplifying this expression. That is first one, that is Boolean simplification I'm going to do. Here all these terms are having A as common. So what I'm going to do is I'm going to take a as common, A into 1 plus AB bar plus AB, sorry, I've taken, right? So it is a B bar C. So simple, right? 1 plus any term is equal to A. So this is just a. You don't need any NAND gates to realize this. So the correct answer is option A, which is 0. So if 0 is not there, then you have to go for 1, because you can do this. You can short the input of the here you can't do it. Okay, then you have to use double NAND gates. So again 2 will be the option, but here since the options having 0, you can choose that one, because you don't need a NAND gate to realize a simple variable, because if you simplify this you get a A. So the correct answer here is option A is the correct answer, which is 0. There is various other questions. That is the next question which we are going to do is also this type of question. There we are going to apply another approach. Okay, let us see that. The Boolean function y is equal to AB plus CD can be realized using how many 2 input NAND gates, that is minimum. That is how many minimum number of NAND gates, 2 input NAND gates you need to realize this expression, that is y is equal to AB plus CD. Options are A2, B3, C4, D5. I'm going to apply here y is equal to, I'm going to write the expression first, y is equal to AB plus CD. Then I'm going to apply the double complement approach here. That is, I'm going to take a double complement. If you take the double complement of a variable, there is no difference, right? There is 0 complements is equal to 0 itself. So I'm going to take the double complement approach here. I'll remove this y. So what is this? According to the De Morgan's law, AB plus CD the whole bar is equal to AB bar plus CD bar the whole bar, right? So if you apply the first complement over this variable or over this expression, you will get like this. Because we know that A plus B the whole bar is equal to A bar into B bar. Okay, sorry, this is a into, not a plus. Okay, so here it is. This is A, this is B. A plus B, the whole bar is equal to A bar, that is AB bar, into B bar, that is CD bar. Okay. So, this is the expression. Now, if you see this, there is a product term with a complement. You can use one NAND gate here, then one NAND gate here, and total there is a product complement. So, third NAND gate here. So, how many NAND gates you need? 3 NAND gates you need. So, if you do this much, your answer is obtained, and the correct answer is option B. Anyway, I'll try to draw this for you. I'll draw it here. That is, first NAND gate is receiving A and B, and the output is AB bar. Then second NAND gate is receiving C and D, and the output is CD bar. So, taking the product of these two and taking a NAND. So, it is AB bar into CD bar, the whole bar. Okay, so this is your realization, that is NAND gate realization. Okay, by drawing of NAND gates. Okay, so how many NAND gates you need here? You need only 3 NAND gates. Minimum 3 NAND gates is required to solve this or for realizing this expression. So such questions can come. So in the earlier question, we don't need any NAND gate because there was only one variable left while simplifying the expression. But here, when we are doing the double complement approach, you can also apply various approaches, but we need to find the minimum number of NAND gates. So try to simplify the expression to that is in that way. Okay, so here the correct answer is option B is the correct answer, which is 3 NAND gates. So these are the questions which I have included in this video. If you want the part 2 of this video, that is if you want the part 2 of digital gate simplification, please do mention in the comment section, because you know that while going for competitive examinations, all the competitive examinations are having this area, that is logic gate questions or simplification questions is sure. So if you want more questions, please do mention in the comment section. I'll be doing more videos on it. So the ISRO scientist examination is going to happen very soon. That is on the 12th of January. I hope you are doing a very good preparation for the same, those who are preparing for scientist examination. And also this technical assistant examination will be coming very soon. So please do prepare your examination, prepare for your examination as good as possible, as fast as possible. Okay, so if you found this video useful for your preparation, please do give it a thumbs up and also share this video with all your friends who are preparing. And if you want more videos, please do subscribe to the channel.